All right, let's get started, and more people can come are welcome. So good afternoon, everybody. My name is Stefano Tempesta. This session today is about the Microsoft Azure Iot Suite. Well, or at least it was 6 months ago when I started planning this session and applying as a speaker for NDC. Things have evolved a lot since then, and now the Iot Suite is actually part of a global and richer offering from Microsoft. So if you allow me, let's change the name to with the Microsoft Iot Solutions, because yes, we'll talk about the suite, but there is much more, a much richer offering in the IoT landscape that would be really a shame to miss out now. And it's so quickly evolving that every month Microsoft is releasing something new. I invite you also after this session to attend the next two I think they are in room 4 with David Glover. They are about services and devices for IoT, so it's very interesting to see how, from this overview, we can go a bit deeper into the actual services and devices for programming the Internet of Things. So, what's the agenda for today? I'll try to cover all of these points, presenting a case study, first of all, so how we actually use the IoT solutions in Azure for something that makes sense from a business perspective, and then analyze a bit of the microservices pattern, a bit of a buzzword at the moment, to try to understand exactly how that applies to the IoT world. And then we go deeper into the suite itself, the hub, which is a bit of a new service, a bit richer than the suite itself. We'll get into the details. We'll touch about machine learning, time permitting, and then a few words about security, because obviously we want to have secure connections, secure devices, and so on. So let's get started. And just 30 seconds about myself, just to introduce who is speaking today. My name is Stefano Tempesta, as I mentioned. I lead the engineering department in EF Education First. I'm based in Zurich, in Switzerland. I'm a former soccer player. I used to play for FC Barcelona, and this is where we won the Champions League. Okay, it's fine. People don't believe me when I say it, right? Okay, I got it. And you can find me online. I wish that was true, though. All right, the case study. Now, that is something that I worked on in my past experience. We wanted to build a single view of a user into a CRM, dynamic CRM specifically. The way we wanted to build for a health beauty company, basically, was to start promoting products disguising as advice or recommendation for a better lifestyle. So we decided basically to start collecting patterns of people according to their different age, gender, location, and promoting lifestyle recommendations and making recommendations in terms of products for specific situations. For example, a woman, 40 years old, traveling from home to work. Today is a sunny day. Don't forget to apply sunscreen number 40 plus B, because it's, it will protect your skin, blah, blah, blah. So all these things basically were based on analyzing patterns, typically using devices like the Fitbit or the Microsoft Band, or from your mobile device, sending location, integrating with the weather forecast service, and then collecting patterns based on different criteria like age, gender, skin type. If you're a bit lighter, if you're a bit darker, the product will be different. Location, as I said. So all this information will feed my hub, which contains all the data, all the logic for making this recommendation. That was, so it was already 9 months ago when we started. So at the very beginning of the IoT functionality in Azure, now it's much more evolved, as we will see. The experience basically was start collecting all these patterns using an Hadoop DB on the back end, using machine learning for elaborating this information and promoting this recommendation to customers through the app. And then extending this also to the rest of the family, for example, making marketing partnerships for promoting additional products and so on. Now, this is going beyond scope, if I has to say, because obviously IoT here is only part of it. But it's important to understand that this experience started connecting services that are like the weather forecast, the location service, and the machine learning for identifying patterns and making product recommendation. All these services now are basically part of what I like to call the microservices architecture. It's a bit of a buzzword like SOA was a few years back, but basically the idea is promoting independent components that can be deployed typically over HTTP REST, typically using JSON in a completely independent structure. This is not IoT only. This applies across the board, web development, mobile development, but it's particularly significant for an Internet of Things solution where resources are scarce and then you want to optimize access to your website, to your CRM, to your devices, obviously, notifications, and have everything managed through an enterprise service bus, which is part of the IoT solutions in Azure. Where is basically the advance, the big change that Microsoft introduced in Azure to facilitate IoT devices and applications? A couple of things for now, just to understand from a design perspective, and then we'll get more detailed into the actual implementation. Service Fabric is a kind of enterprise service bus that is based on the service-assisted pattern, where basically an application or a device will publish, will subscribe to the service bus, sending an inquiry and receiving instruction or commands. When I send an inquiry, it's basically sending information that is being captured by the sensor on the device. That can be a device tracking your location and is sending the location to the server as for communication around, for example, traffic alerts. So in that case, the message is queued, and there is a reason for that, because basically some devices may work on a low power, so they may go in standby, they may not be able to receive information in real time. The bus would basically queue the messages, and when the device is alert again, will receive this information, which is the instruction again. Or it may receive a command. A command is actually not just information in terms of data, but is actually an action to do something. An alert, a notification is also part of the mix, and it typically applies not only to the device itself that is subscribed to receive the information, but it can be any device. You can send an email and then you receive in your inbox. It's not technically an IoT device. It's not a wearable device. No? It's just an email or an SMS, but it's all triggered by the same enterprise service bus. Now, you may have noticed this little funnel here. This is basically meaning there is security applied to each message. And the security is basically saying, as a publisher, I'm sending this information. This information is not granted to everybody that subscribes to receive this message, but only applications and only devices that are authorized to receive this information are allowed to receive the message that is in the queue. And this is done actually in a very simple way by having a unique ID for each device and granting this ID into the device management capability of the Azure IoT Hub, as we will see in a moment. So a device with no ID basically is not allowed to be part of this game. Okay, and Azure, just I mentioned briefly Azure functions. Again, like the Service Fabric, they're not specific to IoT. They can be used across any web mobile solution, but they're particularly useful in this context because by being completely serverless and by being driven or triggered by an event, when an inquiry is sent or a command is sent back as a response, we can trigger a function that can activate additional functionality. For example, I can execute a machine learning algorithm and extrapolate some data, as we will see as part of the demo later. So this microservices architecture is basically something as a foundation to consider before starting even considering working with IoT, because you will notice that a lot of configurations can be done without coding. You can register a device in the Iot Suite, but when you want to get a bit more sophisticated, you start getting into Visual Studio, into coding, and playing with the Service Fabric, with the functions, and with the Iot Hub. So let's have a look at these IoT solutions from Azure. As I mentioned, there are a few things that that were available already 6 months ago and have now evolved significantly. I'll recommend having a start really for beginners to the Internet of Things starter kits. I think I've seen this a few days ago. There are 5 starter kits predefined, pre-configured, and you buy them, and you get a physical package with your physical device in it. That you remember the good old times when we were young and we liked to play with resistors and LEDs and these kind of things and circuits. That's exactly what you receive, a box where you start plumbing all these things and connecting. There is a corner outside there, so if you want, in the main area, if you want to have a play with the Arduino or the other devices, please go. They are all based on Windows 10 IoT Core. And they all come, the starter kits, certified for Azure IoT, which basically means that they are pre-bundled for connecting to the Azure IoT suite. Now, this is very basic. You get the device. It's for playing, to get familiar, to see how that works. We actually will go through a simulation using in Visual Studio, obviously not with a real device, but with a simulated device. We'll see how that works. The suite. Now, the suite 6 months ago, when it was announced, was, oh, wow, I can interact with Bing Maps, I can track devices, I can send signals. So the concept, the principles that I said before in terms of the microservices, the enterprise service bus, that all come into the suite, and you don't even realize. It just works. And again, there is a beautiful domain that they've registered, AzureIotSuite.com. It comes with 2 types of solutions. The predictive maintenance is basically saying, hey, this is my device. I want to have a prediction in terms of maintenance in case of faulty behavior, in terms of wrong data that is sent, so that I can anticipate any maintenance work. So it's kind of monitoring from a maintenance perspective. The remote monitoring, instead, the terminology monitoring is a bit confusing, at least in my knowledge of English language, because it's actually not only monitoring the device, but is tracking the usage of the device and sending the messages that we have seen before and responding with commands and triggering action. So it's a bit more powerful than just from a maintenance perspective, because it's a runtime usage. And this is what we are going to see now, the Azure Suite. So let me switch to here. Yep. So if you go to AzureIotSuite.com and you start your you need an Azure account for that, yes. So I'm logged in with my Azure account, and you want to create a new solution. You get two solution types at the moment that you can create. I'm sure more will be added in the future. These are completely prepackaged, and they come with 4 simulated devices. But you can add also a real one. So as you receive the starter kit, for example, then the starter kit comes with a device. You play with it, you plumb a bit, you make it work. So there are some sensors to monitor, to measure humidity or temperature or location, and then you connect these, you register to the solution in the IoT suite. So the predictive maintenance, anticipate maintenance needs, the remote monitoring, connect and monitor on your devices. So I have already created a solution here so let me just launch one of it. Sign in, yes, of course. When you try to create it, it will take 10-15 minutes. So I just pre-bundle one, otherwise we will wait here for 10 minutes. All right, so that's up and running, and basically there is a connection to Bing Maps, there is some telemetry, so there are some alarm history. What's happening here? There are 4 devices that have been registered for this solution. Again, let me just make a step back to create the context here. The IoT Suite is a bundle of most, if not even all, the IoT offerings from Microsoft in one single solution. They call it Suite because you just open the door, as in you create your solution, and you have everything plugged, plumbed, ready to work with 4 simulated devices. You can add real devices, but it's basically all the services are connected. Telemetry is the more important, obviously, because the telemetry service is using the Event Hub on the back end. Is basically the device sending temperature and humidity to the server. And this is happening on the AMQP, Advanced Message Queuing Protocol. You can do it over HTTPS, you just change configuration, but typically AMQP is the preferred protocol by the event bus for performance reasons mainly. You can scale this to the million of devices. So each device is sending information every other second, I believe, in terms of this temperature, humidity in this case. Then we have a bit of gauges here with this, excuse me, the maximum humidity register, the average, and so on. This is using Power BI tools, very, very simple, nothing fancy, but is again another service that is integrated into the suite. And then the alarm history. Here is basically saying a bit of scrolling here, the screen resolution doesn't help, but basically this device at this time has registered this value, so has raised this rule. Now, what is the rule? The rule is basically saying, and you see, you do everything from the screen. Here is all configured through it's like the Azure portal, basically. For this device, if the temperature is greater than 38 degrees, trigger action this alarm temp rule. That from the name, you can guess is an alarm for the temperature. But it's just a name, just a label. What it actually does, you define later in the action. For this device, if the humidity registered by the sensor, by the device, is greater than 48, execute the rule alarm humidity. So the devices, a step back to the devices, are registered here. I have 4 sample devices, but you can add another device, again a simulated one, so that will help to play a bit with the screen, with the simulation, or a custom one, so a physical one. And then when you add the physical one, you start registering the device, you set the endpoint to connect to, you have to register with a specific ID, which have to be unique, and then the device will basically be visible in the dashboard and even on the map. Map is gone a little bit today. Here we go. So, and then you see there is a map device here. There is another device here. This red one has probably raised an alarm, so it's showing in red. And what is these alarms? These alarms are basically they met the rules. So basically, they exceeded the conditions, and now they have raised this alarm humidity, which is basically raising this alarm. Or this other one is sending a message. You can configure different actions. Here are, this is a bit tricky though, because the action that you can see here, unfortunately, cannot be configured through this UI. You have to go to the Azure portal, into the Event Hub, into the Logic app, so many names, into the Logic app service and register your actions. These actions are actually pieces of code, .NET code that you want to write that do whatever is necessary to send a message, to raise an alarm. Basically, what I'm saying here, the suite is putting together devices, rules, and actions, and when a rule executes, it triggers an action, and the action is a function, hence the Azure function, that basically is .NET code that does something. And this something you basically decide code-wise, and we'll have a look into that when we see a bit more advanced functionality, because this is really a pre-bundle, pre-configure suite, and the level of configuration is just in terms of add the device, set the rule, but then you need to do a bit of coding on the back end in terms of creating actions or custom actions. All right. Questions, doubts, fears about the IoT suite? Otherwise, we'll go into, this is a bit of a recap, just to say that the suite is basically using all these guys. There are a lot of services. There is the hub itself. We'll spend more time in the hub in the next slide, in the next minute. The stream analytics, which is basically the functionality to capture all the telemetry. As a device, I'm sending my information, it goes into the stream, and it goes to the service bus, which is the Event Hub. And then it goes to the Logic app. That's the guy where you can configure the action to trigger. In this case, there was a bit of Power BI. There was an Active Directory because the devices are registered in Active Directory with a unique ID. There was a Bing map. Storage is in a document DB, just to make it fancy, but it can be any form of storage. So this is basically, all this box here is the IoT, is a solution in the IoT suite. Now, it's very important to understand that the suite comes pre-bundle, pre-packaged, and that was great news 6 months ago. I honestly find a bit limiting, and this is why I wanted to change a bit the scope of this session from being on the IoT suite only to the entire IoT offerings. We are not able to speak about all of these guys because it would take hours, but I'll try to spend a bit more time into the IoT Hub and into the machine learning, because I think there is a bit more value there, and because it's connected with the case study that I presented at the beginning. So, the Hub. The Hub is really the beating heart of the IoT offerings. It provides a few things, but the two very, very important, in my opinion, are device identity registry. Each device must be unique, because by having a unique ID, it can create it can authenticate and authorize the device. And because authorization and authentication authorizations are on a device basis, you can basically instantly block the device, monitor the device, wipe data remotely. So there is a direct connection between the device and an active connection between the device and the server, the event hub in the IoT Hub. That's important from a security perspective, as I will recap at the end. It also can block unsolicited network information. The Hub at the end, now coming back to the first slide about the microservices, is an endpoint with some services that an external device or application can consume. If the device is not trusted, or if the client is not trusted, it can't consume the microservices. So any traffic on the communication on the network is blocked because the device is not identified, is not recognized into the registry. And communication is bidirectional. Again, the first slide at the beginning where we were the service bus with the inquiry and then coming back at the instructions or the command. The communication is secured and all the messages are queued because some devices may operate on a lower power. They may go in standby. They may lose some messages. We don't want them to lose messages. Therefore, we queue them into the event hub and send when they are awake again. Service Fabric, coming back this again, but I don't think we'll have time to go into this today, but it's basically complementing the IoT Hub, extending the service bus of the event hub outside of the IoT world. So not only devices, but Service Fabric actually extended to any application. And I'm keen on reinforcing this message because I see an IoT solution, not only IoT as in my little device that sends temperature and humidity signals, is really a part of an overall solution where there may be a mobile app, there may be a website. So you want this information to be channeled and trigger actions, and Service Fabric is the place to do it using reliable services, which basically are typically, not necessarily, but typically RESTful web services using JSON messages, and actors, which are basically a combination of these services, the actors that are indefinitely scalable according to available resources. And the Service Fabric will take care of that for you. It's not like a virtual machine that you have to put in a cluster, you have to load balance, you have to do a bit of maintain the infrastructure to scale. This scales because it's already part of the cloud solution. And actually, you don't need to pay extra in Azure. You pay as you go. So you pay for actual consumption of the fabric, of the service in the fabric. All right, the IoT things. Let's have a look to a simulated situation, now more from a developer perspective. I've created a solution in Visual Studio. Yeah, you can see something here. Want to register the device, then to receive the message from the device to the server, and then from the device itself to send a message. a message is wind speed. Now, what do we need? We need some packages. So to create an identity device, you need this the Microsoft Azure Devices package. So create your solution, your project. Look, for simplicity, these are console application, but it can be a mobile app, it can be a website. It doesn't really matter as long as you use this package. So go into your NuGet, add, and then let's add this reference to your main program. What it does basically is, okay, let me connect to the service bus and then register the device. Now, the way it works is basically, let me go back to the screen here. What you will normally do is from new, come on. So this is the Azure portal, obviously. You go new Internet of Things and create an IoT Hub. This is a service. Now, I'm not creating because it will take a few minutes, but I have already one available here. So let me open the existing one. When you create an IoT Hub, basically you're creating the endpoint, the server that receives messages from the device. You have a host name, which must be known to the device, obviously. And you have also a few keys here to connect to. Let me have a look if they come up on screen. Yes, you have a few keys and connection string to use by the server application. So back to our Visual Studio code. What I'm doing here is basically saying this is my connection string that I copied and pasted from the screen. I have a registry manager, and basically I'm adding the device. All this happen asynchronously with this ID. And if the device already exists, just get the device information. This is the first step. If the device is not registered in the IoT Hub, it will not work. Once you run this, so let's just run this very quickly, and you will see it does only it just retrieves an ID, a key. Once you get this key, you take the key and you put into the device itself. So this is the other little program where I put the device, the key of the device, and now I'm connecting to the endpoint, which is a bit of a stepping here and there, but basically is my public host name for the hub. So the device has to be known to the hub by its key and obviously the endpoint of the hub. Once the device does that, now this is a simulation, so obviously there is code. If it was a real device, it would do this from the device itself. It basically just randomly making up some speed or wind, and then converting into JSON, sending the event, and just doing this every second. So if we run this application, you will see two screens. One is the simulated device that every second is sending this message. I'm device 01, and this is the wind that I'm making up, 8, 9, 10, 9, 11, 10, blah, blah, blah. And this is instead the server side, which is basically receiving this message. So going back to the previous screen, to the original slide of the service bus, we have a device, obviously here simulated, that is sending instruction to the server. The server is receiving and putting into the queue. And obviously the message are continuously received, and this is going through the IoT Hub. So if I now stop it, I think it was Control-C, the device will keep on sending messages, but the hub has been stopped, and the last message received is now gone. But obviously now I'll kill the device itself, go back to the hub, which was this one. Let me refresh the page. And we should see a few more messages that have come into the hub, which is this. So there are two devices connected. One was from a previous session, probably, and 171K of messages have been sent. I mean, this includes also previous tests, obviously. So this is basically the hub itself that is monitoring and receiving the application. When this happens, if you remember into the previous screen of the Iot Suite, I can set some rules to say if the temperature, or in this case was the wind speed, if the wind speed is greater than 20 knots, then send this alert or do this other action. But now we are doing here more at lower level. So we are doing into the IoT Hub. We are doing this programmatically, and now again, in this case, simulating the device, but we're basically getting device and the event hub connected. There is something I wanted to show also, which is here. Yes, on the device side, you need the Azure Devices Client package. That's all you need to get connected. And on the server side, which is this guy here, this project in the middle, you need this Windows Azure Service Bus, which is the event hub, obviously, is the service bus that received the message. And the way it works very quickly, and I will share, obviously, this code after the session. This is really, really for reference, is there is an infinite loop that is stopped only if there is a cancellation request, and the cancellation request was the Control-C. Receive always asynchronously from the event hub, and convert the data because we send as a JSON message, and then in this case just display on screen. In terms of connection, we need the connection string, and there was something here. Yes, and then we create basically a connection to the event hub starting from now, which basically means start recording messages from the current date and time. I don't care about messages that have been sent in the past. Right, okay.
May I just ask?
Sure.
For other things, so obviously this is geared towards small messages, and when I was looking at the pricing, it's kind of, you know, between half a kilobyte and 1 kilobyte.
Yeah.
For some of the messages. If you wanted to send, say, streamed audio or video, is there a kind of video over IP solution if you had that in a piece of hardware?
Yes, I mean, this is now using the AMQP protocol, but you can use sockets, you can use HTTP, HTTPS, so any audio, video can go through different channels, different protocols. Need to go and see on the reference of the Event Hub, but there are many supported. In terms of pricing, yes, they are based on transaction, so on traffic. So the heavier the packet, the more you pay.
So that would go via the Azure Hub, would it?
Yes, yeah.
And it would support real-time video, for example, like fairly real-time.
Yeah, I would say probably fairly real time. Look, this will scale to the millions of messages. I've only played with messages like JSON messages, so text, update on temperature, these things, location. So these are a couple of geo coordinates. In In the case study, we will basically send information about the current weather, the current location, the identity of the person, but it's a JSON message at the end. It can be 1K, 2K, but it never gets that size of audio and video. Although I don't see why not. Yes, yeah.
What's the typical latency? So if it was location updates, that type of thing, could you detect a fence or something, some region, and stop the device from entering it, or something like that in a plausible period?
Yes, look, latency is, if I remember correctly, 5 milliseconds. Obviously, it depends also on the network, on the quality of the network connectivity. But otherwise, server side is nearly real time. I would say real time. Okay. Yes, easy. It's always the network, the bottleneck. Okay. Machine learning. How much time we have? Yeah, we have another 20 minutes. Now, this area is again on the boundaries of IoT because again, you can apply it basically to any service, not just the Internet of Things per se. But it's particularly important because it works well when you have a lot of data, obviously. And the best way to collect a lot of data is from people using several types of devices. In the case study, the beginning that I mentioned, we were programming the Microsoft Band or the Fitbit or an app on your device to basically collect this information. Now, I want to show you this variation of this app, which is not exactly the close start, which is kind of the one that we used. I'm saying kind of because that one will work on the Microsoft Band, and then as I move, will track my location and do some preferences. But this one is a bit more of, more interactive, asking people for their preference. So let me get on screen. Beautiful. That's the app. Here we go. And now this one is interactive. So it's basically saying which concern you would like to address. Aging skin, itchy skin, sensitivity, acne, sun protection. So then I'll select this. What level of UVB exposure do you have? This is really more interactive and say, okay, low level because I'm staying mostly indoor, is raining outside, I'm not going out. My skin is normal skin. Boom. This now sent the service, sent the information to the machine learning service based on my profile that has been recorded before. So he knows that I'm a man, 40 years old, white, Italian background, I'm in Sydney, it's raining outside or whatever, and then it comes out with some product recommendation. If I follow a different path, it will give different results. If I am a different person, it will give different results. This is, the results are all coming from this machine learning using a recommendation algorithm that I will show you in a moment. Take this, which has been a bit interactive because as a person I have input this information, in a context where all this is happening automatically because the devices are sending information about my location, about the weather condition, and so on. And then obviously you have a bit of automation in place, which helps to get this information without user interaction. So let's go to the machine learning things and see how that works. Okay, a bit of screen challenge here, but we should be all right. Now, machine learning that you can see into this azureml.net website comes in forms of projects, experiments, and web services. A project is a project, a collection of different experiments that you do. An experiment instead is a kind of combination. It is a workflow that combines different actions that produce from input data an outcome. There are different types, which are, can't remember on top of my head, so apologies, I need to take this up on screen again, which are sentiment analysis, basically monitor buzzwords, keywords on social media, typically, and identify sentiments. Someone is expressing happiness, sadness, anger around some comments that have been made. Demand estimation, if I supply this product in this quantity, what is the expected demand? So it can be used for forecasts on sales. Outcome prediction, if I do action A, what is the outcome expected? And recommendation, which is the typical Amazon suggestion. People that have bought this have also bought this, this, and that. And on the recommendation experiment is based the case study that I said at the beginning. It consists of two experiments. One is the training of the model, and one is the prediction itself. The training of the model. Now, the machine learning studio, which is this that you have seen here on screen now, basically works mostly in a visual way, as you can see, where you have a number of actions on the left-hand side, from data set, data transformation, algorithm for machine learning, Python and R modules, and a bit of programming itself, that it is exactly in Python and in R. R is a functional language. Now, the way it works is basically, give me some data at the beginning, which, let me see if I can show on screen, which has been collected from the device. So basically, the devices send this information. Come on, here we go. And people of different age, in different educations, in different status, occupation, relationship, race, white, gender, sex, male, there might be some females, and so on. So all this information has been sent from devices that are in the ground and collect this information, and they send it here. Then I apply a bit of algorithm here from a machine learning perspective, without going too much into the science of it. But basically, this is doing a split of data where it basically separates the input data according to some criteria, and then it uses the two-class boosted decision tree, which is basically an algorithm for optimizing decision based on a fork. This is by the two classes. The classes are, I'll take a decision based on some criteria that are set there, and then I split my decision tree in two branches. The branch that has the highest score wins over the next one, over the other one. And so then I keep the winner branch, and then I split this in two, and I keep on going until, by splitting branches and having the winner selected over the other one, I get to one final conclusion. Which is basically meaning I'm training the model. Then I score the model. Scoring is basically the final step in some way, where after training the model, which is basically give me all this data and learn how to use this data, scoring is setting the final result. The final result, let me see if I can see in here. Come on. Is identifying a likelihood of getting a specific product assigned, if I remember correctly. Let me open this. So based on all the conditions, now, male, female, age, race, so which is kind of skin type. Come on, visualize. Get all these data. Come on, why is it not coming out? All right, let me run again, just in case it needs to be running. So obviously, once I create this workflow, I need to run the workflow, which has been already executed before, so all the training has been done. But let's see, in case he wants another run. Okay, all done, finish running, view the results. Is thinking. Hopefully will come up. Now the beauty of this machine learning studio is that it gives all these combination of actions a bit pre-bundled. The challenge is knowing what to use. There is a bit of literature there. There is a bit of documentation. In the context of IoT, it beautifully connects to all what we said before in terms of the Event Hub, the IoT Hub, the Stream Analytics, collecting all this information. If you remember the first screen, here we go, it comes out. If you remember the first screen of the Iot Suite, where there was the Bing map and the telemetry, all that information is coming in real time and is being displayed in real time on screen in the Iot Suite. But on the back end, there was a DocumentDB database, which is a NoSQL DB for collecting this information. I personally have never used DocumentDB, so I can't speak about performance and suitability for these situations. I use Hadoop, which sits a bit better, in my opinion, in terms of big data, because historically it's been there a bit longer than DocumentDB. But you can have all this information basically collecting into Hadoop and then do your Power BI on top of it. Oh gosh. All right. So they don't really like the output here. It was showing something though, right? Let me get back. Well, basically, that it will show. Yeah, he's kind of sleeping, not coming out very nicely. What it will show is for each case, so for each combination of gender, of all the parameters, no? So gender, age, skin type, location, the probability, the likelihood that a specific product can be assigned or not. And then, be slow. The beauty of this is that this can be all made available as a web service. So automatically, once you run the experiment, it creates an endpoint. So the product prediction service, which is basically my web service that has been automatically created and exposed by the machine learning studio. Oh gosh, sorry, I clicked on something that I shouldn't have. Comes up automatically with a web service, which is a RESTful API with a key to protect it, that you can invoke from any device, from any application, and make this information available to your user. And this is what the app is doing. The app is basically saying, give me this API with this key, and then execute and show in the screen. There was a way to, oh gosh. Maybe this one. Yes. Okay, so basically this is the post that I have to do. This is a sample of the request messages, the adjacent messages. You can see where you see all the columns that are transfer the values, and this is the response that I receive, again in a form of a JSON message. So this endpoint is basically being automatically published by this machine learning studio in response to a workflow that generates the values, which I don't know if they are visible here. Yes, here it is. The score probability, which in this case, well, it comes out as 0. But basically, well, this is sample data. This can be excuse me, read by your device, by your app, and then displayed as we were seeing before. Some products, so if they come with a product probability higher, then it will come up in the list of recommended product. So this is a bit of integration between the two things, between the IoT world, the machine learning. So I say it's based on experiment, and then they publish into a web service. And AzureML.net is the website, as said, and this is a bit the way it works. No? So you take the data set, do your magic with the algorithm. In this case, we use a predefined two-class boosted decision tree. There are several ones. You need a good understanding of machine learning to get through all of them. If none of the predefined algorithms work for you, you can write in Python or in R. Then you train the model, which is basically prepare all the information and do a bit of denormalization of data. Then you score the model, which is basically define the output. You know? In this case, the probability, which is my product recommendation. Now, last word about, any question about machine learning is such a large topic that will require a session per se, and I try to bundle these in 10 minutes. Doesn't make really justice to it, but is getting greater visibility in general in the Azure offerings, and now there is a new service that came out a few weeks ago, the Cortana Predictive Intelligent something, which is basically using voice commands to interact with machine learning algorithms to receive information also in voice. So getting even more sophisticated. I really didn't want to put this into the mix today as well. But what I do want to recap is some key concepts in terms of security, because probably, look, some are common sense that apply to any solutions that is either mobile or web or IoT. But some are a bit more specific. So, for example, you need to have a unique ID for your device. That we said is basically a device to Event Hub connection. If you don't have a unique ID, you can't even connect. And that will secure your channel, secure your communication, and allow for remote wiping of your device, these kind of things that obviously add the security to the device itself. And then some common sense. Keep your system updated. Do auditing of your devices. Typically use an MDM, a mobile device manager, a solution for having all your devices up to date in terms of security patches, updates, operating system, and then track the communication path. The telemetry functionality that is not only useful for sending information about humidity, temperature, wind speed, but is also used for tracking. So the device is actually alive. There is a bit of a heartbeat. It's sending a signal. Is working. So collect information that are useful, but also collect the heartbeat of the device. So track the communication path. And because devices, especially the IoT ones, tend to and should do. To consume less energy, so they go offline or they go in standby or they in a low power mode. The service-assisted communication protocol or patterns that we have briefly mentioned at the beginning helps in queuing the messages and making sure that they are received when the solution, the device is online. This obviously is a specific to the IoT world. It doesn't apply, to mobile and web. And I think that's it. That's, again, me when I was an astronaut on board of the NASA Space Shuttle. But thanks for listening. Thanks for coming to this session. I think there's been a lot of things that are just a brief overview. Again, I remind you, if you're interested to get deeper into the IoT, into the Internet of Things, to follow up with the next 2 sessions in room 4. A couple of minutes for questions, then I'll stick around a bit. Doubts, fears?
Is there a microservice in Azure to push firmware upgrades to the
I will probably do that through an MDM platform rather than as a function. If it is to update a device, yes. If it is for updating software, yeah, the MDM I think will work still better, honestly. Yeah. And if there are no other questions, thank you, and have a rest of the day beautiful. See you later.